In this video, we are trying to understand how to check whether a series is convergent or divergent, right? Suppose we have a series, any series. We don't know about its sign, positive series or negative, anything. Generally, we have a series like this. We don't know whether n is non-negative. We don't know these things. Any series, a this is an any series, right? All right. So now let's consider its nth partial sum. Sn is denoted by the nth partial sum. A sub 1 plus a sub 2 up to summation of first nth terms. So this is called a partial sum, nth partial sum of the series, right? If you subtract, so s, definitely s can define s sub n minus 1, which is n minus 1 partial sum, right, up to a n sub n minus 1. So Sn, the difference between these two partial sums, is equal to nth term of that series, of the series. So suppose that series is convergent, then we know the limit of Sn goes to a some number. This one also goes to a number as n tends to infinity. Then what happened to this one? This becomes very small as n tends to infinity. That means that a n terms, the magnitude of the quantity of AX become very small, very small. That means an goes to 0 as n tends to infinity, right? So more details. If you have a sequence which converges to 0, right, as n tends to infinity, what can you say about all subsequences? So I think you haven't learned that part in this course. So suppose this is your sequence here: a sub 1, a sub 2, a sub 3, a sub 4, right? This is your sequence. You can find, so if you consider even terms, say a sub 2, a sub 4, a sub 6 up to, and a sub general term 2n, all even terms. So this is a subsequence of this sequence. And can you give another subsequence? So I consider only odd terms of the original sequence. So a sub 1, a sub 3, a sub 5, the general term a sub 2 and minus 1. Here, and when n is equal to 1, this is a sub 1. When n is equal to, this is a sub 3. This one. So this sequence So this sub n minus 1, this one is a subsequent of the original sequence an, right? And this one also subsequent, or you can write this one a sub 1, a sub 20, a sub 100, dot dot dot. We don't know the generator, so this one also a subsequent of that original one, a sub n, right? So here we know that this sequence converges to 0 as n tends to 0. That means all these subsequences converge to the same limit, of, the original here. So all subsequences of this sequence converge to the same limit, right? So for instance, I think you understood this one. Now let's take an exam question. Let me take that. So let's take this one up here as summation n goes from 1 to infinity x sub n, where x sub 2n minus 1 is equal to this, and x sub 2n is equal to negative of that for each n. So this is the series. These are positive quantities. Yeah, same thing. Here also same thing. But look at the sign. Plus, minus, plus, minus, plus, minus. And these quantities are positive. So this is called an alternative series, right? Even though this is an alternative series, but look at subsequences. Just focus on their subsequences. Here, this is a subsequence of x sub n. Here, n divided by n plus 1, right? So we know that if the series is convergent, so xn, or here an, the limit of xn should be equal to 0 as n tends to infinity, right? That means all subsequences of this sequence, this is the sequence xn, x sub n is the original sequence. These are subsequences. So these are subsequences. If this series is convergent, we know that xn, the limit of xn is equal to 0, right? This one is true. That means all subsequences should be, the limit of all subsequences should be equal to 0, not other numbers, right? So look at this one. This is a subsequence of that sequence, right? So as n tends to infinity, what happened to this term? This term converges to 1. So you found a subsequence, right? Its limit is non-zero as n tends to infinity. Its limit is non-zero. That means the original series does not converge to 0 as n tends to infinity, that means this one is divergent series. This one is a divergent series. So if it is convergent here, so look at this. You have a series. You consider n partial sum, right? You know an is same with difference between these two partial sums. We know if that this series is convergent, then the sum of this series is finite. That means partial sum converges to a finite value L as n tends to infinity. This one also converges to the same limit L. So when you are considering the difference between these, then the limit of an should be equal to 0, right? So this means original sequence, the limit of original sequence is equal to 0 if this one is convergent. That means all subsequences of this sequence should be equal to 0. But here these are two subsequences of this series of this sequence, right? So this one converge this one converges to 1, which is a non-zero value. That means the original sequence does not converge to 0 as n tends to infinity. That so if the limit of original sequence is not equal to 0 means this series is not convergent, and therefore this one is not convergent, right? So even though this is an alternative series, don't have to um, use alternative series test. It says this should be monotonically decreasing, and this quantity must be reducing to 0. Otherwise, this alternative series is not convergent. No. If these quantities are reducing to 0, and this sequence, if you consider these, let me get that definition, right? Yeah. Alright, look at this one, alternating series test. Suppose that we have a series sum of ANs, and either AN is like this. So here B sub n are positive quantity. These are positive quantities, right? Here look at this here. For all n, this is non-negative, right? Either this way or this way. So this quantity, this positive quantity or non-negative quantity should be reducing to 0. Then that series is convergent. So this is the alternating series test. But if you have any series like this, we don't know the sign of a sub n, right? So this is the partial nth partial sum, n minus 1th partial sum. If you take the difference between these two, you get a sub n. And if this series is convergent, this partial sum goes to, it has a limit. This one also the same. This is a partial sum, this series sequence converges to a number L. Then what happened to an? So an becomes very small as n tends to infinity. An goes to 0 as n tends to infinity. So this is true for any series. This is true for any series. So this means all subsequences of an is converge all subsequences of this sequence converge to 0, not to other value, 1 or non-zero value, right? So in the problem here, so we have two subsequences of this sequence. So here look at the limit of this subsequence. That subsequence converges to a non-zero value. That means the original sequence does not converge to 0. Therefore, this series is divergent. This one is divergent. Alright. I hope you understood this one very clearly now. Right? I will I will bring another video on this to understand this concept very nicely. Alright, see you.